So our next talk is Migrating AmLight from Legacy to SDN, Challenges, Results, and Next Steps by Geronimo Becerra from Florida International University.
Hello. Good afternoon. Well, good afternoon again. First of all, I would like to thank the program committee for the opportunity for us to share our experience. My name is Geronimo. I'm from Brazil, but I work for the Florida International University. And the idea of this presentation is to share our experience and migrate our network from the legacy approach using VLAN, spanning tree, to a full SDN approach. So first of all, let me introduce some of the names you're going to see here along the presentation. First of all, one of the most important is the empath. Empath is the academic exchange point that is based in Miami, is operated by the Florida International University. The Southern Light is the academic exchange point that is based in São Paulo, is operated by the Brazilian National Research and Education Network and the Academic Network of São Paulo. And the AmLight, which is a distributed exchange point, interconnects the empath to the Southern Light, and another exchange point, another point that we have in Chile, and is responsible to provide connectivity to all Latin American research and education networks, to all the other research and education networks around the world. And all of this is possible through the partnership that was established a long time ago between all these members, and they are networks, academic networks, and the U.S. National Science Foundation. So just a short recap. I know that most of you know what SDN is, but just to be sure that everyone is on the same page. The software-defined network decouples the control plane from the data plane. Now all the forwarding actions being installed in the network device are being managed and populated by the external controller. This external controller that has the whole visibility of the network needs a standard interface to talk to all network devices, assume that you can have different vendors and different kinds of devices. And today, the most popular protocol for this interface is the OpenFlow. Most part of you heard about this. The OpenFlow has from version 1.0 to 1.5 that was released in the end of the last year. Most part of the vendors already support the OpenFlow 1.0 and or the OpenFlow 1.3. And the most part of the current suites we see in production support what is called the hybrid mode. The hybrid mode is the mode when the switch supports some of the ports using OpenFlow and some of the ports using SDN. Using legacy. So you can have legacy and OpenFlow in the same switch. But some vendors also support what is called the hybrid port. The hybrid port supports both modes in the same port, which is very good for incremental deployments and for you to have a backup between both worlds. So you can have VLANs and OpenFlow flows in the same port, and one provide the redundancy for the other. And with SDN, everything in your network, all the network activities will be responsibility of the controller. So this controller will be responsible for the provisioning, create prioritization, rate limits, deploy new protocols, secure everything that you want, because the controller will have a visibility of everything that you have in your topology. So if you want more information about the OpenFlow, SDN, or migration use case, you can go to these links. The slides will be available. So what was the step-by-step that we create for our project? The idea here is exactly do this. Introduce the methodology we use and show how this applies to our scenario. First of all, it seems kind of obvious for most part of you. You have to have a good documentation of your network. You need to know all the protocols you have. You need to know all the services and applications you support, because knowing this is how you're going to choose the right application for you. Is probably at this moment, if you decide to migrate your network, you're not going to find an application that supports everything that you have. But let's say that you decide to start slowly, it's good to know everything that you have, even in case small things that sometimes we don't take in consideration, like link aggregations. So document everything. In our case, the AmLight it still is a layer 2 transport network. So pretty much everything that is layer 3 in our network is managed by the exchange points that I mentioned before. AmLight just provides connectivity between them. And at the AmLight, we had the link aggregation using the Brocade multi-chassis trunk that creates like a virtual switch. You can connect two chassis, and from the user point of view, you are just one link aggregation. In this solution, we use LACP. We also use VLANs and the Brocade solution for the per VLAN rapid spanning tree, and the port mirroring for troubleshooting purposes and monitoring. The second step is the assessments of your network. This is, of course, also very important because you need to understand what your current devices support. So does your device support OpenFlow? If yes, what version, 1.0, 1.3, 1.4? So you have to be sure about this. And other protocols like netconf, YANG, because you need the configuration part. Also, you need to understand if these have to be very clear for you. What is the current deployment phase of the OpenFlow in your brand, in your vendor, in your device? Because some switches right now, some vendors consider the OpenFlow production for their deployment, but some of them are just in the beginning, but sometimes this is not very clear. So you have to have this in consideration. And one thing is, well, the OpenFlow creates a lot of specification, but it doesn't mean that all the vendors are compliant to all the specifications. So this is very important for you to know what kind of optional features you have in your vendor. So does it support the OpenFlow 1.0? And 1.0 does not support QoS, for example. But if you have 1.3, what kind of optional features you have for the mirroring table? What kind of features you have for the port group? Your vendor supports link aggregation, for example. Your vendor supports intercommunication between legacy and OpenFlow flows. All of this you must know. And one, of course, very important thing is, does your device support a hybrid port? Because this is going to make your life a lot easier. In our case, I'm not going to go through all of the details, but we only had Brocade devices. We had Brocade MLXE and the XMR. They're both chassis. And one small switch, CES brand, that is a Metro. And the moment that we deployed the OpenFlow, the only option was the OpenFlow 1.0. This was in August last year. But now Brocade also supports 1.3, was released in December. So things that you need to understand, be very clear about your device. The number of flows supported, how many flows is supported per interface, per line card, and for the whole box. This is very important because if you have a huge network and you decide in the future to deploy IP or install the BGP routes in your OpenFlow entries, you need to understand what is the capacity of your device. In our case, the main limitations are the number of flows per port. We saw 4,000 for the chassis, 2,000 for the CS. But as I said, we are just working with VLAN, so this was not a problem. The support for hybrid port, this, as I said before, is very important, but we realized one of our switches did not support this. And we had to work around to get a solution for the incremental deployment. I'm going to talk a little bit more later. So you need to understand the number of controllers available, the kind of matches that your device supports. For example, you want to do everything based on layer 2. Most part of suite support layer 2 match. But if you want to do something like layer 2 and layer 3, you need to make sure that not just the switch support, the software supports, but you also have to be sure that all the line cards you have in your device support. It's very common that different line cards have different kind of supports, and some of them support only layer 2, sometimes layer 2, layer 3 matches, and sometimes even only layer 3 matches. So this is the kind of thing that you need to understand. In our case, even though our network is only layer 2, but we want to use layer 2, layer 3 matches because as an academic network, we have another plans for providing researchers in South America access to our network device so they can create their own flows. And statistics, this is one of the most important things. Some switches do not support S-flow or NetFlow in the port when you enable OpenFlow. So if if SFlow or NetFlow is something that is very important for you, you need to be very careful about this. Also, you cannot just rely on the statistics from the OpenFlow flows, the OpenStats, because some switches don't support statistics for all the flows. Some switches don't support statistics like for packets per second and bytes per second at the same time. Some line cards have different ways to do the account of the traffic. And so this is something that you have to be very careful. In the past, most part of us use the SNMP to have access to the VLAN information, and now that you have replaced for OpenFlow entries, you need to be sure that the OpenFlow stats are going to provide you the same results that you're expecting from the SNMP. Also, when you have OpenFlow ports, in our case, the Brocade does not support layer 2 control protocols, so you cannot have a spanning tree in the port. Even though you can have the hybrid port that is legacy and OpenFlow in the same port, you cannot have the spanning tree in the legacy side of the port. So this forces sometimes you to change the topology that you have. And you have limitation as the amount of VLANs support in the hybrid port. In our case, it's just 40 is not a problem, but again, you have to pay attention to this. And then one thing there was a problem for us is because the Brocade does not support link aggregation. You enable OpenFlow in the link aggregation ports. So every flow that has to follow the link aggregation port, we have to create a workaround. And also, the Brocade does not support communication between legacy traffic and OpenFlow traffic within the same box. So you have to create like an external loop, connect a fiber between two ports in the same switch, or using another switch to make this work. So this is the approach that we use, create an external loop. So the OpenFlow flow can go to the LSCP ports, so we don't lose the LSCP approach that we have in the backbone. And always have in mind that hardware will always matter. The SDN creates in its perfect world, all the switches will become black boxes. You won't be necessary to care about what is inside each box, but this is not true. At least so far, we have seen that different memory, different FPGAs, different ASIC, each vendor has a different way to handle the same stuff. And as I said before, it's not because my vendor support OpenFlows that my vendor is OpenFlow compliant. So you have to be very careful about the hardware you have. The step 3 would be the controller, what controller and what orchestrator to use. The controller is the software that works in the southbound interface. It's the software that talks OpenFlow to the switches. It provides the API for your application. The application or the orchestrator is the business application. Is the service that you provide. It's the layer 2 VPNs, layer 3 VPNs, the IP traffic, QoS, everything that you have in the network is an application. So there are a lot of different controllers available. Most part of them are open source. Some support OpenFlow 1.0, some support OpenFlow 1.3. But the great thing about the SDN now is the application, it's not the controller. The controller is just an API to OpenFlow translator. And this is what we miss right now, because as we are just creating this movement, there are just a few applications that could be useful for everyone. So in this case, that you don't have an application, what do? Do you create in-house? Will you try to use one that is available and deploy just a short part of your applications, like only the VLANs, not the layer 3 or not the multicache? So this is something that you have to decide. And one thing that we have is we decide to do a virtualization of the network, because we want our researchers in South America to use the network. We want them to provide, to create an application, install their flows directly in our switches, because we want them to have flexibility to test multipath TCP or failover for any kind of specific application like big data or video stream, whatever they have. So in our case, we had to deploy OpenFlow 1.0. We know we still have a lot of limitations, but for beginning was good. The controller that we used was the NOx, is part of the Internet 2 OESS. Internet 2 is the the US academic backbone. They create this software for them in the past just to support layer 2 provisioning. So it's pretty much VLAN and MAC address that you can create flows. And we decide to use the OSS because it has a good API and it supports OSCARs. OSCAR is a software for multi-domain layer 2 provisioning. In the case of the academic networks, a little bit different from the commercial networks. The most part of the research, they want their direct layer 2 path between them and the remote side. Sometimes between Brazil and South Africa, for example, they want a layer 2 path for trying their experimentation. And this is very complicated when you have a lot of different networks in the path. So having solutions like OSCARs or any NSI agent, there is another protocol, makes our life a lot easier. So that's the reason we decide to use the OSS. But it also applies for a lot of people that have a very good and very big layer 2 backbone. And for the virtualization, we decide to use another tool created by Internet 2 called the Flow Space Firewall. The Flow Space Firewall works on the top of the Floodlight, which is another OpenFlow controller, just to create the separation of what every slice of the network has, what kind of VLAN range, what set of ports each application could have. Another very important question, step 4. How do you create your control plane network? Most part of discussions about the SDN does not cover this topic because this is like how the legacy network will provide access to the SDN network. So most part of the controllers today, and most part of the vendors, they don't support communication, control plane communication, OpenFlow communication between the switch and the controller on the top of one OpenFlow flow. So you need to have an external network like IP network to reach your switch to then install the flows and make all the data path flow. So it's very important for you to define where to install your controller and how to make the connectivity work for your controller to reach your switches. Because I cannot say that no vendor support in-band communication because I haven't tested all of them, but all the switches that I have a test did not support this. So the out-of-band is one approach. You need to be sure how to make the connectivity to each switch that you have in the network. Maybe you need out-of-band access, one megabit per second link from the carrier or another interface from your device. So in our case, we have 2 switches in Miami. We have 1 switch in São Paulo in Brazil and 1 switch in Chile. And this is a ring topology. So in this case, all the switches only have 2 links. And both links, in the case specific from Chile, as I said before, there's no hybrid port supported. So it has, based on the fact that it does not support hybrid port, I cannot use their ports, the links that I'm paying to reach the switch. And this is the problem where the out-of-band is a problem. So we had to rely on another academic network to provide us just 1 IP address, 1 megabit per second link connect to our switch so we can reach our switch to install the flows and make the network work. But this might be a problem for some of you, and maybe you have to pay for this out-of-band if you don't have this kind of partnership. Security, of course, you have a lot of things. For example, the communication between the switch and the controller should be using SSL or not. And the first shot, it looks like, oh, it's obvious, let's use SSL. But as everything here is new, the code inside the switch is new, the controller is new, the application is new, it makes it a little bit more complicated for you to just use a TCP dump for troubleshooting. So we decide not to use because we have a very controlled approach. But also the amount of flows you have, if you decide to have virtualization, provide and support different users manipulating your switch, you need to define the amount of flows of each application can install and the flow insertion rate limit, how many flows can be inserted by second. So all of this you have to define. And the troubleshooting, again, is a very important topic, especially if you try to use the passive. In this case, the switch receives the flow direct from your Linux command line, but we have to find a solution to do this in a security approach. So in our case, we decided to go without SSL This makes our life a little bit easier for troubleshooting because, again, everything here is new and we are always seeing things that we need to work on. We limited the slides to 4,000 flows, all of them using layer 2, layer 3 matches. Today we have something around 306, and we limited to 40 flow inserts per second. And today we see that 15 is more than enough. It's most part of the time communication for LLDP and topology discovery. And we're still working on the troubleshooting in the passive way. So now let's say that you're motivated to do the deployment in your site. So what kind of things you have to pay attention despite all the others that I talked to? You're gonna need new skills. This is the most obvious. If you're just a network engineer that only works with the network, you don't get involved in Linux or application or coding, be prepared. You have to learn a little bit about Linux because of the controllers. You need to learn how to read logs and especially coding. You may be a little bit of Python or a little bit of Java because most part of the controllers use Python or Java will be very useful for you, especially for creating troubleshooting tools for you or sometimes to integrate the software, the SDN world to your Cacti or Nagios or Zabbix application. You start with the Mininet. The Mininet is an emulation network software that you can create your topology, simulate the link speeds, everything, and use your external application in controlling that virtual network. But then you have to create a physical test environment with the same switch that you have in production. This is now fundamental. Most part of you probably have this as a testing environment, but this is the kind of thing that you have to keep like forever because now the new code that one component of the stack has changed, you have to test in all of them. You need to be sure that how that code affects the switch, how the code affects the virtualization, the controller, the application, the user interface. So it's very important that you have this scenario always available for you to test. And of course, do it gradually. Don't try to migrate everything in your network from one shot. So in our case, we started in April 30 last year, deployed everything in August 30. We developed a few tools. We learned, of course, a lot about the OpenFlow and Python. Linux was part of our routine, so it was not that complicated. And along the supercomputer of last year, we had peaks of 55 gigabits per second only on the top of the OpenFlow interfaces. So train your team, document everything. This, again, seems obvious. Keep the networking test, the test environment available. You have to do this forever. It might be a waste of time or a waste of CapEx, but it's important to have this. And be prepared for surprise, of course. No vendor or switch is mistake-free. And in production, we have Brocade, but we have we have other devices. We have Cisco, we have Juniper, we have PK8, and we have seen that all of them have problems. So always have your disaster recovery plan available. So for the future, we still need to define some methodology to test the new vendors, new suites, validate the suites work, a methodology for troubleshooting. This is the thing that we are working now. And make sure that the full OpenFlow flows are forwarding the traffic according to what you expect. This might be not very clear, but sometimes the switch does not work properly as the way you expect. And we have new applications in mind, like the DDoS control used in AskFlow was presented on the last Open Network Summit by Brocade. And we are working now with the Georgia Tech to establish a network-defined exchange point. And so we can connect a lot of SDN islands from our users through our topology. So just the last slide, these are the results we saw in our network. As we are an academic network and we have a lot of peers, and we had that situation, everyone wants a layer 2 path across in sometimes 7 networks. And we usually are the central contract point for all of them. We have seen in the past that sometimes create a single VLAN can take 5, 12, 8 weeks, for example. So the most simple scenario took at least 5 days. And to create this single VLAN, sometimes it took like 10 emails exchange between all the network involved from the moment that they request, from the moment they confirm that it's working. But we had case like it took 2 weeks or 8 weeks to have a single VLAN working, and more than 100 emails were exchanged. So what we're seeing now that with the SDN involving and the multi-domain protocol working fine, all of this is done in less than a few seconds. And there is no need for emails. Our users, they know they have ACLs. They know what ports they can use. They go in our software, click, and endpoint A, endpoint B, and the network is provisioned. So this was one of the main achievements for us. And the second one, as an academic network, we are very focused on the programmability. So now our users, researchers, not just from the computer science, but from arts and the scenic grid that works with video, they have access to our switches. They can do the flows according to their needs. They have information about statistics, about ports, about interfaces turning up and down, but also, most important, they create the flows according to their needs, to their application, their research. So that's it. Again, thank you for the time. Thank you for the opportunity, and I'm open for questions.
Thank you, Geronimo. So please state your name and company.
Jan Linko, Google. 2 questions. Could you please share data on convergence time in case of failure in your network?
Well, in our website, we have a lot of information. This thing we can, I'm not sure what exactly everything that is being shared there, but maybe we can work on this together.
Yeah, I'm just curious, like link failure, device failure, how much traffic are you losing in case of failure?
Yeah, well, the traffic we have available, I'm just not sure about the configurations of the switches we have, but again, we are an academic network. We have everything open, everything you need. It's just not available there because we're still working the website.
And second question, sorry if I misunderstood you. You said that you are configuring your devices through third-party network, and you decided not to use SSL. So basically, all your communication is unencrypted.
Yeah.
And what is the security model in this case?
No, well, in our case, in Miami, we have our switches directly connected to the controller. So in Miami was easy. In São Paulo, in Chile, in fact, we are working to create a IPsec between the router from our partner to our controller. But everything that we have so far is the environments. This environment for the control plane is very restricted. Yeah, but I know it's very insecure, but it's the best way for us to make sure that the controller is sending the flows exactly the way we expect to see them.
Thank you. Any more questions? So thank you again, Geronimo.